Okay, let's pull back the curtain on one of the unsung heroes of our modern world, the humble cable tray. We're going to get into the really critical engineering choices behind the hardware that keeps literally everything from data centers to giant factories powered up and connected. So, here's how we're going to break it down. First, we'll get a handle on the problem itself, what I'm calling the cable conundrum. Then we'll explore the two main solutions engineers turn to. After that, we'll dive into how their physical shape dictates what they can do. And all of that leads us to the final and most crucial part, making the right engineering choice. All right, first step, the cable conundrum. Let's talk about this massive and usually completely invisible challenge that every single modern building has to solve. So, what really holds our modern world together? It's a huge question, but the answer isn't some abstract idea. Nope, it's something tangible, physical, and it's running unseen right over your head, in the ceilings, and behind the walls of almost every building you walk into. That's it. The answer is just an unbelievable and potentially chaotic amount of cables. Think of them as the arteries and veins of our infrastructure, pumping power and data exactly where we need it. But how on earth do you manage all of that without it turning into a total mess?
Well, the elegant engineering solution to all that chaos is the cable tray. And listen, this thing is so much more than just a simple shelf. A cable tray is doing three critical jobs all at once. It's providing serious structural support, it's creating order out of chaos, and this is key, it allows for thermal management by letting air flow around the cables. So the goal is simple, manage the cables. But there are two fundamentally different ways to get there. Let's dig into the main designs that engineers have to choose from. Now look, there are other specialized types out there, like these super lightweight wire mesh trays you see everywhere in data centers. But for most big industrial and commercial projects, the choice really boils down to these two, and their names give you a huge clue about what they do. On one hand, you've got the heavy lifter, which is all about pure strength. And on the other, you have the uniform support, which is designed for versatility. And this is where the engineering gets really cool. The physical shape, the actual geometry of each tray is everything. It's what directly defines its strengths, its weaknesses, and exactly where it should be used. Just think about a ladder tray for a second. Its incredible strength comes from a shape that perfectly mimics one of the strongest structural forms in all of engineering, the I-beam. It is purpose-built to carry heavy loads efficiently over really long distances. How does it do it? Well, it's built from two incredibly strong side rails. We're talking 1.5 to 3 millimeters of steel that carry almost all of the load. Then you have these cross pieces, or rungs, that connect them and support the cables. This simple, open design is brilliant because it's not only super strong, but it also gives you maximum airflow.
Okay, now for a complete contrast. A perforated tray acts more like a solid sheet. So instead of focusing the load onto rungs, it distributes the weight of the cables across its entire surface area. This design uses a continuous base, usually a bit thinner at 1 to 2 millimeters, and it has a bunch of holes punched out of it. That helps reduce weight and allows for some ventilation. Because of that solid base, it's absolutely perfect for supporting bundles of smaller wires that might sag or fall through the gaps in a ladder tray.
So you've got these two very different designs. How in the world does an engineer actually choose between them? Well, it's not a guess. It's not a gut feeling. The decision is driven by data, and it all boils down to one single international standard. And that standard is IEC 65137. Think of this as the rulebook. It gives engineers a clear, data-backed framework for every project because it classifies trays based on their safe working load, which is really just a straightforward way of saying how much weight a tray can safely hold per meter. And wow, this chart right here just lays bare the massive difference in performance. Your standard perforated tray might handle about 50 kilograms per meter. But now look at the ladder trays. A Class C version triples that to 150 kilos. And a heavy-duty Class D, a whopping 200 kilograms per meter. That is 4 times the load. And that has huge implications. More strength means you can put your supports farther apart, which can slash your costs for brackets and installation labor almost in half. So let's just put it all together right here. This table makes the trade-offs crystal clear. For raw load capacity and getting the absolute maximum airflow, the ladder tray is the undisputed champion. It's the go-to for heavy power cables. But if you're supporting delicate bundles of data or control wires, the uniform surface of a perforated tray is what you need. even if it has a lower load rating.
Picking the right tray is so critical because that one decision, as this quote says, affects everything else down the line. It's going to determine your span length, how many brackets you have to buy, what material you choose, like do you need corrosion-resistant stainless steel because you're in a coastal area? And most importantly, it directly impacts the safety and the long-term health of the cables themselves.
So, in the end, it all comes back to the specific demands of the job, right? It forces engineers to make a calculated choice. Are you going to need the brute strength of an I-beam to carry the absolute heaviest loads, or do you need the versatile uniform foundation of a flat plate to protect those delicate bundles of wire? The right answer always depends on the cables it's destined to carry.